Hello, this is our demo video for lab5 IoT Hub and mapping with ThinkSport and OwnTracks. In this project, we successfully set up an end-to-end IoT system that connects GPS and sensor data from a mobile phone, sends it to the ThinkSport platform, and visualizes the data on a live dashboard. Our team worked in an equal and collaborative way. Everyone contributed to different steps of the setup, such as configuring the AWS EC2 instance, installing ThinkBoard, connecting the OwnTracks application, and building the dashboard. Whenever one member faced a problem, others provided guidance and support. For example, when we built the dashboard, the map did not show the device location at first. After discussion, we realized that the latitude and the longitude key names were not set to lat and long. And once we fixed that, the map started working correctly. Yeah, it's here. The latitude key name and the longitude key name, we need to replace them. And this is what we did step by step to finish the lab. First, we download and install the OwnTracks application for our own phones. And then we set up ThinkSport Community Edition on AWS. We launch a new instance called lab5 and follow the instructions to set it up, including the security group and the subnet, the networking configuration. So and then we associate an elastic IPs to it so that we can use SSH to log in our instance at our own computer. Next, we follow the instructions to install the Java 17 and the ThinkSport service. This is the step we recorded in our report. This is the screenshot. These are the screenshots. And we configure database of ThinkSport like MyCircle and PostgreSQL. Add extra line in configuration. These are the extra lines in the configuration file. And we run the installation script and start the ThinkSport service. Now we can enter this URL, replace localhost by our elastic IPs to get access to the ThinkSport website. Here, this is the ThinkSport website. And after we finish this, we can do the next step. Alright, the next step is to configure ThinkSport. In this step, we need to add device on our ThinkSport first. First we need to log into the ThinkSport. You can use 3 accounts that are provided in the instructions file. We choose the middle account to log in, and then we need to add devices and set up some details of devices, like we choose our own name of device and click the add button, and then it will pop up a window showing connectivity for HTTP, MQTT, and QAP for different operating systems. What we need to do is to write down the URL and copy it to our phone and paste it in this place, so we can connect the ThinkSport and our OwnTracks app on our phone. After this, we can use sending function on our phone to send data, and we will see the real-time data was sent to the device's latest telemetry. Here we can see the location, the altitude, and the battery. All the information will be shown here. After this, we need to build a dashboard to achieve some visualization functions like our real-time location on map. We can see different widgets, and we add this OpenStreetMap. Don't forget to change the type and choose our own device and add some data case. Or for this data case, we can customize our own data case that we want to show on dashboard, like battery, the velocity, etc. And click the appearance to change the latitude key name and the longitude key name. After finish all of the above steps, we can see our real-time location on OpenStreetMap. Now we finished the configured scenes board and test it.
In this demo, we present an application that can record sports data and visualize the user's trip on the map. By switching the recording mode from menu to move, the mobile app continuously uploads location and status data whenever the user is moving. So on the trip map, these data points are connected to form a sports route. We also added additional keys to the map like these: velocity, battery, and altitude, and we added the tooltip like this. So after this work, when you click on the points on the map, you can directly see the speed, altitude, and the battery level at that moment. Like this. This setup enables both real-time monitoring during the activity and post-activity analysis afterwards. For example, we can analyze how speed changes around the trip, or check if the phone battery is sufficient for a long-distance checking.